So this is hydroelectric power plants. So what is hydroelectric power? The U.S. Department of Energy states that it is a renewable source of energy that generates power by using a dam or diversion structure to alter the natural flow of a river or other body of water. So what's the problem with hydroelectricity and its power plants? Hydroelectric power is no longer the most optimal way of generating energy. According to Daniel Oliveres, who has a degree in electrical and computer engineering, the management of hydroelectric generation in power system operation faces challenges such as variable renewable energy integration, climate change effects, and new optimization techniques. This means that the world is being impacted because of the new energy being made, and we are having to adapt because of it. So some examples include the limited amount of locations to build hydropower plants. Joseph Malwinski, a manager in the field of environmental and social governance, states that a reservoir is the most significant source of environmental impacts of hydroelectric projects, but it also provides the highest level of hydroelectricity supply services, causing troubles within the field. Another example would be the construction. Bin Chen, an assistant professor in the Institute for Health Services, and his colleagues demonstrate that hydroelectric dam construction causes direct or indirect detrimental impacts on river systems by altering the water flow pattern and reshaping natural habitats. Then there's political impacts. Emeka Daniel, a geography and environmental studies professor at Taraba State University, states, the study has examined the politics and controversies surrounding the Mambia hydroelectric power project. The study findings indicate that the project has been stalled for over 30 years. Emeka is demonstrating that the growth of these hydroelectric dams is being put off and causing confusion. Lastly, there's economic growth occurring. Economic problems occurring, specifically growth. Benjamin Sovacool, professor of engineering policy at the Science Policy Research Unit, suggests that hydropower is prone to slower rates of economic growth, important for the perspective of national policy. Benjamin sees hydropower as detrimental to economic growth and knows the importance of this problem.
Solution 1, increasing the efficiency of existing hydroelectric plants. To start off, our first way of making hydro plants more efficient is by placing photovoltaic systems on the surface of reservoirs. A photovoltaic system consists of solar panels placed on the surface of water. These systems take up no more space than what the hydro plant already uses and are constantly generating energy throughout the day. They're kind of like a cold-blooded animal. Solar panels work best at cool temperatures, so when placed on water, they stay cool and optimal. Another way of making hydro plants more efficient is by using shade balls. They're plastic, dark gray, and have between a 4 and 10-inch diameter. Shade balls are also placed on the surface of reservoirs. Their main function is to prevent evaporation, but they also protect the water from contamination. Implications. Photovoltaic systems will lower energy bills because with them, more energy will be produced so that it is no longer in shortage. However, they also impact the environment. They prevent surrounding life from accessing the water, causing loss of diversity. Different can be said about shade balls. Shade balls reduce algae growth by stopping sunlight from entering the water. Thanks to shade balls, the water stays clean and safe to drink. Limitations. Photovoltaic is a new technology and has not yet had the chance to be used thoroughly. These systems are also not commercially available, which is a big problem. As this graph by Statista shows, 75% of dams in the U.S. are privately owned, which means 75% of dams do not have access to this technology. These systems are also unpredictable. Moving on, according to Rosa Maria Martinez Espinoza, shade balls can save water and prevent water quality problems, but their high cost, energy use, and environmental pollution raise concerns. As this quote shows, shade balls actually harm the environment. To add, shade balls often use more water than they save because they are filled with water to maximize the amount of sunlight blocked. In the end, these ways of increasing efficiency for hydro plants still have some issues that need to be sorted out.
Our second solution is to reduce the reliance of hydroelectric power plants and instead increase use and production of other power plants like geothermal, wind, and solar. Geothermal, wind, and solar have the capacity to effectively move away from the usage of hydro plants. However, in order to do so, there will have to be a major increase of these types of power plants. One way to reduce costs is to increase the use of geothermal energy production in oil fields, as the land is already being used by oil companies and it's ready to supply generators with enough heat to generate power, according to Xiaozhou Wang from Petro-China Research Institute. These technologies will have to be adjusted, work together in order to maximize efficiency. Similar things are said for both wind power and solar power. Ulrich Deckner, who has a PhD in nuclear engineering, states that small plants can be implemented as backup energy producers for oil. The time to build these plants will also be shorter than hydroelectric plants, as one hydroelectric plant in Nigeria construction was delayed by over 30 years, according to Amike Orimi from Taraba State University. The problem limiting geothermal and wind energy from truly replacing hydroelectric power and eventually fossil fuels is a problem of limited land. Geothermal plants require natural resources of heat that are either hard to get to or are detected as being a natural feature in some areas. For large wind and solar power plants, the large amounts of land used need to be both flat and barren of big structures. Finding and readying that land needed for geothermal, wind, and solar will take some time, but will still be shorter than the longer delays of hydro plant work. Another problem that limits the use of geothermal, wind, and solar plants is their relatively underdeveloped and under-researched technologies, which result in inefficient generators. According to Ulrich Deckner, wind power plants have short lifetimes and cost hundreds of millions to maintain a power plant each year. It also brings up another problem. According to Andrea Paolillo from the University College of London, these geothermal wind and solar power plants only provide similar amounts of energy of hydroelectric power plants, increasing the number of power plants that are needed in order to fully replace hydro plants.
We have decided that solution 2 is the better solution. These are the pros and cons. Although solution 2, it would take a long time. Solution 1 would as well. This is due to the fact that more efficient technologies would have to be researched and developed and implemented into dams. Solution 2 would be very expensive, as it would require the implementation of wind turbine fields, as well as geothermal power plants, and their maintenance. Solution 1 would be expensive as well, because grants to research and develop more efficient hydroelectric turbines would have to be made. Installation of these turbines would be expensive, and maintenance would be pricey while the technology is still emerging. Solution 2 would result in more land being used for power generation, with the large quantity of land needed for wind turbine fields and the large size of geothermal power plants. However, solution 1 might result in land destruction. This is due to the fact that if a dam fails, then the other side of the dam is flooded rapidly, which can lead to its destruction. This is from the Association of State Dam Safety Officials. Thank you. Here's our work site.